In this video I found I screwed up on the part, so you'll find out about that in the video. And I do a few trinkly jobs around getting the aircraft much closer to being taxi worthy, if not airworthy. So join me, let's see what I've been up to. Come on then. Okay, issues. I've screwed up on the aircraft. My flying turnbuckles, this is landing wires, should only have a maximum of 3 threads showing, and with it under tension I've got more, I've got 5. I thought I was going to get more stretch in the cable, and so it's wrong down here as well. So luckily, sort of, the front flying wire can replace the landing wire, and I just need to make up 2 flying wires for both sides. It's a difference when you're doing things. I couldn't tension it all and everything else when it was I was doing partial rigging in the shed and that, and I thought I got it right, but not quite, obviously. So hey ho, I've got to take these wires off. This one goes into there, and I've just got to make up 2 new wires, which are going to be about 1 inch longer. Swine, beggar. What else have I been up to while I've had it like this? So it's been rigged up at the position. All the bolts are now in on the wing root end, so that's all done, and the little cover plates are on. That's good. Now I've got this cover plate fully on, and shortly get the other one on, and then I can start mucking around with the tail rigging wires and struts for the back end. So it's all a bit wizardry, and I can get the ailerons sorted out as well, so we can get that. I've got that all adjusted. It's underneath the seat, so you won't be able to see it from here, but the rod ends are all adjusted. I've just got to put the bolts in and lock it with a split pin. Right, so we've got the forward flying wire into the landing wire position. That works. So go and make up those other wires, as I said earlier. So what else have I been up to? Right, back end here, all the hinge screws have come out, had thread lock put on them and put back in, and the 2 side cover panels have gone on. Yes, it's not quite a perfect match on colour, I know. That's the Oratex paint for Curtis Blue, and that's Curtis Blue Oratex, but it's not quite a perfect match, and it's the first time the 2 bits have been next door to each other, and I'm not going to repaint them. I'm just going to have to live with that bit. It's not that bad a match. But there we go. So yeah, next stage to have a little look at, I'm thinking, is like split pin the main wheels. Okay, so the wheels are split pinned on their axles. I'm now starting to work through what's going to happen with the stays back there. Well, I know what happens. I know that I had them previously assembled, so there, but I've got to make up the cables going down. Again, that's diversion from the Fisher set. Fisher used cheaper stays for that. I've gone to cable. There we go. So another day's worth of work on the weekend. Cleared up. Okay, there's the tailplane cables made up, and it's not tightened up down here yet, So I've got to put a spacer washer and another washer onto the bolts where the stay goes on. A spacer washer to stop the head of the bolt trying to penetrate into the tailplane itself. But other than that, they're in place at the top end, so they're ready to go. Not too far out, and all set up so that I put packers underneath. I'll double check when I put the spacers in with the clino to make sure the horizontal stabilizer is horizontal and the vertical fin is vertical. But hey, next task is I'm going to play here with my Pitot static bits, do a little bit of bending and see if I can get something to conform with the way I want it to go, and we'll see what we produce. Okay, so there's the Pitot static setup, Pitot static underneath, going along, running pretty much parallel to the cord line with the 3D printed mounts on there, and it's all reconnected inside here down there, so that should be a goer now. What I've got to do is I've got to do a leak check, at least on the Pitot system. It's quite easy to do it. I'll put a syringe in here, plug it on, put a bit of pressure onto it with my better half looking at the airspeed indicator, and then I'll leave it on there and make sure that the pressure doesn't drop, and that'll give me an indication of how leaky or non-leaky the system is. The instruments themselves have been checked out, so they should be okay. Anyway, another day's work effectively done. Ticking off things on the list all the time. Hopefully in the next couple of days I'll have the flying wires made up and in, and as soon as I've got the flying wires made up and in, I can do a taxi test. I'll play around doing that, burn off the fuel, get the last bit done, and I'll do the oil change and put the cowl on. Probably won't be this week though, the way things are. All the controls are good to go, so hey ho. Okay, let's see if I can answer a question which I've got from Outlaw Flyer 7868. He's been following the channel for quite some time and often asks questions. But here we go. Can you tell us why there are 8 holes at 45 degrees around the Pitot tube and how they work? Well, sorry, just got to correct you there, Outlaw. It's around the static tube. The Pitot tube is the upper one. It's just a straight tube pointing directly into the airflow for the pressure to go down and do your airspeed indicator. The static system takes the ambient air pressure around the aircraft for running the altimeter, vertical speed indicator, and to help the ASI do true airspeed. Now, a lot of microlights just have the vent inside the cockpit, but I've gone to doing it in a more traditional way and having it out on the wing strut. So why 8 holes? Well, it doesn't need to be 8 holes. It could be 4 holes, it could be 6 holes, it could be 24 holes. In reality, we just want a few holes, and fairly small bore, so they're not affecting how the airflow is around themselves too much. So hence I've gone for 0.8 millimetre. And it's nearly always an even number when you're doing it as a tube system like I have, and you go, that way you can drill straight the way through from one side to the other. And the reason behind that is, if you imagine there's the static tube itself sticking forward, the head. If you change the angle of attack or something like that compared to the airflow coming in here, this side you've got a high pressure, and this side you've got a corresponding, virtually equal negative pressure. So by having a hole on this side and a hole on this side, it'll average the pressure out inside the tube, so that you don't end up with large fluctuations in pressure as you go into side slips, pitch, dive, or change your attitudes and things like that, and have your altimeter waving up and down accordingly. And that's why I've gone for 8, because it allows for sort of semi-side angles and various other bits and pieces. So hopefully that answers that question. And then the next question he asked was, how come the rudder isn't weighted? So I think he's talking about the count of weight in the rudder. Mass balancing, as it's termed on flying control surfaces. Well, mass balancing is used as an anti-flutter system. If you've got the centre of gravity too far back on a flying control surface, it is more prone to flutter. And if it flutters, it can destroy itself. And it can also induce problems in other parts of the airframe as well. In the case of the rudder, I've got quite a large aerodynamic balance horn at the top. That's how it was designed, and that's really just to increase the effective rudder area. If it just went straight up, we'd have less effective rudder area. But also, because that balance horn is going in front of the hinge line, it sort of makes out that the centre of gravity is further forward compared to the sort of centre of pressure of the rudder, and that actually does help reduce flutter. It also reduces the force required on the pedals in flight, so that's quite nice. But the rudder system itself is heavily damped by the two things at the bottom end of my legs called my feet, so the chances of you getting flutter on the rudder are relatively low. It could still happen, but because you've got balance horn there, it's great. So adding weight to balance out the rudder is just adding weight really on this aircraft at the speed it's going to fly. If this was a higher performance aircraft, then yes, I'd be adding counterbalances on that. But I'd also be adding, far more importantly, counterbalances on the elevator and the ailerons. They're far more critical. Ailerons especially, because it's got a really sharp trailing edge. On most higher performance aircraft, the elevators have a sharp trailing edge as well, and the rudder. In this case, the trailing edges of the flying control surfaces are quite rounded, and therefore they're less susceptible to flutter anyway. And then the last bit he goes, how come, will there be a trim tab on the rudder? If so, what degree will the tab be set at, and how do you determine what degree the tab should be set at? Well, no, I'm not anticipating putting a rudder trim tab on. I might put a trim tab on the aileron, because the aileron forces tend to stay pretty much the same throughout the flight regime. You do have a bit of torque effect and things like that, but you set that up for cruise so you can let go and you don't get any roll. With the rudder, generally you've got your feet planted on the pedal, so it's not a load that you're going to feel a really heavy load. So it's not a case of I'm going to take my feet off and I want the rudder to stay sort of central, and So honest answer, as I'm sort of waffling on, is no, I'm not going to bother putting a trim tab on the rudder on this aircraft. Again, the loads are going to be fairly light, especially with the big balance horn, and my feet are going to be permanently on there because there's no room in my cockpit to put my feet anywhere else. But I may put one on the aileron. Now, how do you determine what position, angle to set the trim tab at? You don't. Simple answer. You put a trim tab on in a neutral position, and then you test fly the aircraft and find out if it requires an input into the flying control system. If it requires an input, you put the trim tab on that control surface in the opposite direction to the way you want that control surface to move, and you do that by a small amount and test fly it again and see if you need to do more or less, and you test fly it again, and usually by the sort of second or third test flight you've got it dialed in pretty close to where it needs to be to have hands off flying or feet off flying. Now hopefully that answers your questions out more flight. Right, I'll crack on, and I'm just finishing off connecting the wing tanks to their respective pipe work to go down for being able to feed the main tank when required. Right, let's crack on. Okay, sorry, I was a bit remiss. Haven't put in the haven't got the video clip of the wing tank connections going together. I've used clear fuel tube, the same as that I have here, to connect from the wing tank here round to the top here. The reason for using that is it's thinner than the normal braided stuff, and wasn't enough space to put the normal braided type fuel tube around there. And then I've got my little cover plates. I've put edging strip around those so that it doesn't chatter and chafe into the covering. It's got a spring clip going forward, and it's just held in place with wire locking wire there. So that's done. The fuel system is now complete. Okay, I think I'll call that the end of the video. I've still got to do the Pitot system leak test. That's one job I've got to do. I've got to make up new flying wires when the cable arrives. That's another job to do, get those fitted. The spacers for the tailplane, the horizontal stabilizer section, so that's another job I've got to do. And then little tasks which I can get on with. I can put the aircraft up, rig it in the rigging position, do all the drops with plumb bobs, and mark out for the datum points and positions for the undercarriage compared to the datum points for the aircraft way. That's a task that could be done. I also could do the last of the ground running. About 15 minutes I'd like to do on that, which I'm going to use up also for doing initial taxi tests. And then I can do an oil change and put the cowl on fully. So that needs to happen really before I do the aircraft way itself. So I'm not sure exactly what I'll get up to in the next week or so, but we've got at least got a couple of weeks of work there before we're going to be anywhere near ready to fly. We're still waiting for the metal to do that closing strap, which also needs to have reinforcing bits put into it so it can carry the aerial. So I don't know, maybe 3 weeks of work away before we're looking at committing aviation, or being ready, somewhere near ready to commit aviation. We'll see how we get on anyway. So keep yourselves fit and well, and look after yourselves and your family, and I'll catch you in the next one. Bye now. Thank you for watching. If you enjoyed the video, please hit the thumbs up. You can subscribe or even hit the little bell notification for future videos. Any comments would be appreciated, and I'll try to get back to you as soon as I can. Remember, go fly and feel the sky.